Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. Okay. As usual we first come to its statement. Okay. A free neutron is an unstable particle and beta decays into a proton with the emission of an electron. How much kinetic energy is available in the decay? Okay, dear students, here we do not give time to explain nature of beta decay. We come to solution. Before starting our solution in a formal manner, we introduce a few snapshots, only two snapshots. Okay, only two snapshots. In first snapshot, charge and mass are given. Okay, basic mass is proton, neutron and electron. Proton 1.007276 atomic mass units, neutron 1.008665 atomic mass unit, electron 5.486 into 10 to power minus 4 atomic mass unit. Next snapshot is a table of physical constants. Okay, from this table we will choose relevant figure. Okay, moreover, this table has been included in so many previous problems that there is no need to explain it in any nature. Okay, now we come to its solution in a formal manner. Okay, using E equal to mc square relation. Okay, delta E equal to delta mc square. What we slight modification we have made. Delta E, change in energy, is equal to delta m, change in mass, into c square. Moreover, we have used m capital. Actually, because this m is a result of addition or subtraction of various masses. Okay, so it is denoted by capital M. Okay, E equal to mc square, or delta E equal to delta mc square. This becomes equal to mass of neutron minus mass of proton minus mass of electron. Okay, we once again go to statement. Okay, a free neutron is an unstable particle and beta decays into a proton with the emission of an electron. Okay, now we come back to the place where we left this problem. Okay, so delta E becomes equal to mass of neutron is given in the table, mass of proton is given in the table, mass of electron is given in the table. Okay, 1.008. All these three values are those which are shown in the snapshot. Okay, this. Okay, we have taken these three values. Okay, this minus this minus this. Okay, so from this table shown as a snapshot, we have chosen these three values. However, we have yet not disturbed c square. Okay, c square is as it is. Okay, by subtracting second and third quantity from first quantity, we get the result 0.008404. Okay, moreover, dear students, in the last mass of electron, In the table it is given as 5.486 into 10 to power minus 4, but we have um, transferred that style in this form. Okay, so our result has become to this extent. Now we are going to deal c square. Value of c is 3.0 into 10 to power 8 meter per second, but here we are going to use value of c square in terms of million electron volt per u. Okay, now we move to table. Okay, here one atomic mass unit is equal to 931.5 million electron volt over c square. Here c square will be shifted to other side of equality and it will be shifted to numerator, while this one u will be shifted on other side of equality and it will take the place of c square, that is it will be shifted to denominator. Okay, so c square will become equal to 931.5 million electron volt over u. So here we have made this arrangement. This u will be cancelled with this u and our result will become 0.783 million electron volt. Okay, this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.